This is video 17.1. We will be solving an electrostatics problem using Coulomb's law. The question: charges 1, 2, and 3 are arranged as shown below. We'd like to know what is the magnitude of the net force on charge 3. Step 1 is to find the force magnitudes. We do this using Coulomb's law. Here the constant K is Coulomb's constant. Q1 and Q3 are the charges, and R is the distance between them. In the units that we're using, the Newton, kilogram, Coulomb units, K has the value of 9 times 10 to the 9. The charges are 85 and 50 microcoulombs. Microcoulombs means 10 to the negative 6. The distance between them is 78 centimeters, or 0.78 meters. Here we're only interested in the absolute value because we're looking for the magnitude. Combining these numbers gives 62.9 newtons. We can do the same thing for charges 2 and 3. This gives 38.9 newtons. Now remember that forces are vectors. So if we wish to find the net force magnitude, we have to break each of these forces into its components, add the components, and then we can take the sum of the squares and the square root to give us the magnitude. So we'll start by finding the horizontal component. Now for the force between 1 and 3, this is easy. They are aligned in the x direction, so there is no y component. And because the force is attractive, since charge 1 is negative and charge 3 is positive, the force is directed in the negative x direction, so that the x component of this force is simply equal to negative the magnitude, which is negative 62.9 newtons. For the next force, we'll draw in the different components. That interior angle is 30 degrees. The x component is the magnitude times the cosine of negative 30. Negative 30 because it's 30 degrees below the x-axis. However, cosine of negative x is equal to cosine of x for any number x. So this is simply equal to 38.9 times the cosine of 30, which is 33.7 newtons. To find the total x component, we add both contributions, and this gives negative 29.2 newtons. We can follow the same procedure to find the vertical component. The vertical component of the force between charges 1 and 3 is 0, so we just write 0 newtons. For force between charges 2 and 3, I draw in the components, and we see that the vertical component is the sine of negative 30. Now for sine of negative x is equal to negative sine x. So we can take out the minus sign, and we just have 38.9, which is the magnitude between charges 2 and 3, times sine of 30. This gives negative 19.45 newtons. The total y component is equal to the sum of these components, which is just negative 19.45. Step 4 is to find the net force. the net force, the magnitude of the net force, is equal to the square root of the sum of the squares. If we plug in the values that we've just found in steps 2 and 3, we arrive at our final answer, which, to the level of accuracy we're concerned with, is 35 newtons. And that concludes video 17.1. Check out PhysicsX on the app stores. This revolutionary physics app for smartphones and tablets contains over 100 videos and 500 multiple choice questions designed by education experts. It's been proven to improve scores for intro college physics, AP physics, MCAT physics, and more. Just look for the blue icon.